Hi, it's me, Rohit, and today we will be taking a look at 2013 Aime I number 7. So let's jump right into it.
A rectangular box has width 12 inches, length 16 inches, and height m over n inches, where m and n are relatively prime positive integers. Three faces of the box meet at a corner of the box. The center points of those three faces are the vertices of a triangle with an area of 30 square inches. Find m plus n.
So we're given in the problem that the area of the triangle is 30. Also, we can figure out what the sides are by using the Pythagorean theorem 3 times. Um, since we have the centers over here, you can just form three right triangles by joining this point over here to the midpoint of this segment and this point to the midpoint of this segment, and that forms a right triangle. And you can do that so on and so forth for each side of the triangle. So as you can see, the side of the triangle that is 12, that is formed by the 12 and the 16 segment, it will have length 10 because when we take half of each of the sides, so that's 6 squared plus 8 squared, we get 10 squared. So therefore the length is 10, and we will go ahead and mark that segment on our diagram. Yeah, this one, 10. I've called this side x, the one that's m over n that we're trying to solve for, that's x. So we have this side, which is going to be formed by the side lengths of the right triangle legs. It's the hypotenuse of the right triangle with legs x over 2 and 6. So therefore, the length of this side will be square root x squared over 4 plus 36. It's not the neatest, but you get the idea. And then for the other one, we have, using similar logic, we have x squared over 4 plus 64. And that's because it's formed by legs that were x over 2 and 8 long. So summing those squares and taking the square root, we get those legs. We have the triangle over here, and here we've put it on the side that has the base of 10, because that's a nice round number to work with. And since we know that the area of the triangle is 30, right, this altitude that I've dropped, it must be 6. Now, on one side we have the x squared over 4 plus 36, and on this side we have x squared over 4 plus 64. Now we can actually create an equation with one variable and solve for x. So the way to do this is to find this segment, this small segment over here in terms of x, and this other segment over here in terms of x as well. Pardon that. Let's see here. We have 6. So let's just write all of this out. We have x squared over 4 plus 36, and since this is one of the legs, take the square of that, which is 36, subtract it. So these two 36 cancels out, and we get that it's x over 2. This small length over here is x over 2. And now for the other side, we have x squared over 4 plus 64, and again we have the 6 over here, so we're going to subtract the square of that, which is 36, and we get x squared over 4 plus 28. So it's a little bit ugly, but now we're going to make an equation. So now what we can do is we can solve for x in terms of an equation, and this was possible because we expressed the two different lengths that made up the base, which was 10, in terms of x. So the first portion, or the first length that was part of the base, was x over 2, and the other leg or length was x squared over 4 plus 28, the square root of that. And now we're going to move x over 2 to one side to make our math much easier. Now squaring both sides, we get 100 minus 10x plus x squared over 4 equals x squared over 4 plus 28. Thankfully the x squareds over 4 cancel, the quadratic term, that's really nice, and we get that 72 equals 10x, which means that x is 36 over 5. Now the problem asked for m plus n, which we have right here because this is a simplified fraction, so that's simply 36 plus 5, which is 041, which is our final answer.